Hello everyone, and welcome back to another mind-blowing facts video. In this video, we will answer the following questions. Will a bullet fly forever if fired in space? Is the blink of an eye faster than the speed of sound? Why is it said that sunbathing in the morning is better than sunbathing at other times of the day? What is the average human bite force? What is the total length of human DNA? If we were to fire a bullet into space, ignoring any collisions with celestial bodies, how far would it travel? Since friction in space is almost zero, and the universe is expanding at an accelerating rate, the bullet would theoretically continue to travel for an infinitely long period of time, but not forever. Firstly, space is not a perfect vacuum. Cosmic dust particles and gas molecules, such as hydrogen and helium, are scattered throughout the interstellar and intergalactic medium. Theoretically, these would create a tiny amount of friction when colliding with the bullet, and, still theoretically, this would slow down the bullet's speed over time, possibly after a few to tens of billions of years. Secondly, also theoretically, the gravitational pull of stars, galaxies, or black holes that the bullet passes by would alter its trajectory, and at some point it would surely enter the orbit of something. If it's a planet, the bullet would burn up in the planet's atmosphere. If it's a star, the bullet would vaporize. If it's a meteorite or asteroid, the bullet would shatter or embed itself straight into the meteorite or asteroid. This possibility is extremely unlikely, but it's a theory to consider nonetheless. Even if we assume that the bullet is not affected by frictional forces or the gravitational pull of celestial bodies as mentioned earlier, it still cannot travel forever. Simply put, nothing can exist forever, including our own universe. The heat death of the universe is one of the possible endings for an expanding universe like ours. This scenario suggests that over time, stars and galaxies in the universe will run out of fuel and move far enough apart that the universe reaches a state of zero free thermodynamic energy, meaning it can no longer sustain any motion or life. In short, nothing lasts forever. And neither does a bullet shot into space. Some people wonder if a blink of an eye is faster than the speed of sound or the speed of light. It's true that a blink, along with musical notes and how quickly an X turns into a stranger, is one of those common measures used to describe the speed of something. However, a blink is not as fast as you might think. While it's true that the average human blink lasts between 100 and 400 milliseconds, or 1/10 to 4/10 of a second, the distance traveled during a blink, which includes both the downward and upward movement, ranges from 2 centimeters to 3 centimeters depending on the size of your eyes. This means that the speed of a blink is around 0.0625 to 0.25 meters per second, or 0.225 to 0.9 kilometers per hour, which is much slower than the walking speed of an adult, which is around 5 kilometers per hour. Some people wonder, why is morning sun good, but not afternoon or evening sun? Most of us have at least once in our lives heard our parents or someone say that sunbathing to get vitamin D, right? Actually, there is no vitamin D in sunlight at all. The reason why our parents encourage us to go out to play in the sun is because sunlight, or more specifically UV rays in sunlight, is the catalyst for vitamin D synthesis to occur in the human body. However, would you be surprised if I told you that the best time to sunbathe is not in the morning or afternoon, but in the middle of the day? Why is it in the middle of the day? To answer this question, first we need to understand more about the concept of UV rays. You may already know that ultraviolet rays are invisible electromagnetic radiation with a wavelength range of 10 nanometers to 400 nanometers. However, you may not know that there are 3 types of UV rays: UVA, UVB, and UVC. UVC rays have the shortest wavelength, ranging from 180 to 280 nanometers. They are the strongest and most harmful type of UV ray to human health. Fortunately, UVC rays are completely absorbed by the ozone layer of the Earth's atmosphere. UVA rays have the longest wavelength range, from 315 to 400 nanometers. They are the most common type of UV ray, accounting for up to 95% of the UV radiation that reaches the Earth's surface. They have the ability to penetrate the lower layers of the skin, causing darkening wrinkles and freckles, and accelerating the aging process of the skin. The remaining type is UVB rays, which have an average wavelength of 280 to 315 nanometers. Up to 95% of UVB radiation is absorbed by the ozone layer, with only about 5% reaching the Earth's surface. UVB mainly affects the upper layers of the skin and can cause sunburn, tanning, and even skin cancer. Of the three types of UV rays mentioned above, only UVB has the ability to stimulate vitamin D synthesis in the human body. However, unlike UVA, which is present in sunlight at all times of day, UVB is mainly present during the sunniest times of day, which is in the middle of the day, or more broadly, from 10 a.m. to 2 p.m. However, before you decide to spend your entire afternoon tomorrow sunbathing outdoors, remember that in addition to helping the body synthesize vitamin D and supporting calcium absorption, UVB can also cause skin cancer. For those wondering, where did the UV rays with wavelengths from 10 to 180 nanometers go? The answer is, these UV rays are easily absorbed strongly by oxygen molecules in the atmosphere and therefore can only exist and propagate in a vacuum environment. For this reason, they are called vacuum ultraviolet. Some people wonder, how strong is a human bite? According to National Geographic, the average bite force of an adult human ranges from 150 to 200 psi, pounds per square inch. This is equivalent to placing an object weighing from 23 to 31 pounds on an area of just 0.39 square inches. To give you a comparison, the average bite force of a dog is around 230 to 250 psi, equivalent to the pressure of 35 to 39 pounds on 1 square centimeter. Speaking of dogs, the breed with the strongest bite in the world is the Kangal Shepherd dog from Turkey, which is said to have a bite force of up to 743 psi, equivalent to the weight of 115 pounds pressing down on 0.39 square inches. In contrast, a lion's bite force is only around 650 psi. The record for the strongest bite, or the creature with the strongest bite, still exists, and it is none other than saltwater crocodiles with their 3,700 psi bites, equivalent to 573 pounds pressing down on 0.39 square inches. The title of the creature with the strongest bite ever known, or at least known and modeled by humans, still belongs to the megalodon, a prehistoric shark that went extinct about 3.6 million years ago, reaching a maximum length of 60 feet and weighing up to 60 tons. Their bite force, as simulated by computers, is up to 40,000 psi, or 6,191 pounds per square inch. To put it in perspective, the bite force of an adult megalodon is equivalent to placing a Ford F-150 super truck on your fingertip. What is the total length of human DNA? First of all, DNA is a molecule that carries the genetic information of all known living organisms and many viruses. This molecule is in the shape of a double helix, formed by two strands wrapped around each other. Whether by accident or design, this arrangement is extremely clever and space-saving, similar to holding the ends of a string and twisting it continuously in two opposite directions. It has been calculated that if the length of the DNA molecules in each cell of the human body were stretched out, they would be about 2 meters long. You may find other sources with different figures, such as 1.5 meters, 2.3 meters, or 3 meters. In today's video, we will stick with the most widely accepted result, which is 2 meters. Multiplying this number by the approximately 37.2 trillion cells in each person's body, we get a total length of all DNA molecules in an adult body of about 74.4 billion kilometers, which is about 496 times the distance from Earth to the Sun. Continuing to multiply this number by 7.7 billion, we get the total length of all DNA molecules in the entire world, assuming everyone is an adult, which would be approximately 572.9 quintillion kilometers, equivalent to about 60.6 million light years, 606 times the diameter of the Milky Way, and equal to the distance that light, the fastest thing in the universe, travels in 60.6 million years. Let me know your thoughts by commenting below. Which fact impressed you the most? If you like this video, remember to like and comment. Don't forget to subscribe to the channel and click the bell to be more knowledgeable regularly. And now, goodbye and see you again.